Okay, these should be pretty easy for you at this point. Multiply the diagonals, set them equal to each other. What do we get? We get 16a equals 32 times 4, or 16a equals, just a trick, because I'm fond of showing you tricks. When you multiply something by 4, you're really multiplying by 2 and then multiplying by 2 again. That's what multiplying by 4 is basically doing. So I can do this in my mind. Basically, I double 32 and I get 64, and then I double it again and I get 128. That's what it is. Okay. Now I got to divide both sides by 16. So 16a divided by 16 equals 128 divided by 16. A equals. And I know what the answer is, partly because of another trick that I know. I'm going to write that trick over here. We just had this problem. We came up with 128 because it was 32 times 4, right? Well, I've taught you a trick that says you can take half of one number and double the other number and get the same answer. So if I take half of 32, I get 16, and I double the other number, I get 8. So that means that just like 32 times 4 is 128, also 16 times 8 is 128. Why do I care? Because if 16 times 8 is 128, then 128 divided by 16 equals 8. This is a fact family. Okay, you've sometimes seen these triangle flashcards. I have a set in my classroom, and I'll show them to you if you want. And it basically says this, like if you have 3, 4, and 12, you can essentially say, what's 3 times 4? 12. What is 12 divided by 3? 4. What is 12 divided by 4? 3. Any two numbers that multiply together to get a third number, you can divide that third number, the product, by one of these multiplicands, one of the numbers you're multiplying, and get the other one. So if 16 times 8 is 128, and you can see basically what I could do is I could just say I'm gonna rewrite it in with different numbers, and in particular the numbers that I'm using, 16, 8, and 128. Then we can say, okay, if 16 times 8 is 128, then 128 divided by 16 is 8. Just need to be able to see numbers doing that and working that way, because maybe it takes a little work to get your mind around, oh, I see how those numbers work. But then once you see it, it just makes everything easier for your whole life. So it's worth a bit of time and effort to try and get your mind around it, because everything else becomes so much easier. So that means that the answer is 8. And do we have a choice there? 8? Yep, we do. See. So for number 10, I'm kind of going to do a little bit of the same thing I did before. First of all, let's multiply the diagonals. That times that equals that times that. And you get 9m equals 4 times 54. I'm sorry, 54 times 4. Doesn't matter. Now, you might have noticed that I said this before on the last problem, that multiplying by 4 is just multiplying by 2 and then multiplying by 2 again. So I'm going to multiply 54 times 2. That's 108. And then I'm going to multiply 108 by 2. That's 216. So I got 216 here. 9m equals 216. So 9m divided by 9 equals 216 divided by 9. Or m equals, and now you can just do the math over here on the side, 216 divided by 9. 9 goes into 21 twice, 18. 3 left over, bring down the 6. 9 goes into 36 4 times. Done. So the answer is 24. And that's A. Okay. Now, I just want to show you, since we're here, might as well show you this before we go on. As I said, I'm fond of tricks, showing you tricks. This number right here, 54 times 4, right, got you 216. So basically, if 54 times 4 gives you 216, this is related to, and it works together, the same idea as what I was saying before about how if you double one, take half of the other, it's the same. We can separate out a factor. We can separate 54 into 9 times 6, because 9 times 6 is 54, right? That's like that, times the 4 equals 216. So if I did the associative property, I regrouped these instead of 9 times 6 or 54 times 4, I'm going to regroup them like this. 9 times 6 times 4, and I'm going to group these together. Okay, so essentially what you get is now 9 times 24 equals 216. All equivalent. And why do I care? Because remember, what I'm trying to do over here is do 216 divided by 9. So again, if you multiply two numbers together to get a product, you can take the product and divide it by one of the numbers and get the other one. In fact, let's do that by saying, this is what I mean. I'm going to divide both sides by 9, like that, to cancel that out. And then you can see that that's 24 is equal to what we got as a product of those two numbers divided by one of them. And you can see that that's there, and its resulting amount is there. So all I was trying to show you there is that you can see, I can see that 54 is a multiple of 9, 9 times 6. So I already know that when we divide by 9, it's going to work out nicely. And whatever this divides to be when you divide it by 9, 6. You multiply that by the 4 to get your 24. Well, you missed all of that, but I just did several minutes of this problem and then realized that I had recopied the problem incorrectly. My fault. Can't blame anybody else for that one. Okay, so let's do that right. We've got n minus 6 times 3n plus 1. Okay, and that is equal to 3n times n minus 5. So first thing we're going to do is we're going to FOIL, first, outer, inner, last. Okay, first, 3n squared, outer, n times positive 1, positive n, inner, negative 6 times 3n, negative 18n, and last, negative 6 times positive 1, negative 6 equals, and now I'm going to just distribute this. We're not foiling because 3n is a monomial term. We're just multiplying like that. And we get 3n squared minus 15n. Yeah? And let's combine like terms. We've got, on this left-hand side, we've got a couple of n terms. We've got a positive n and a negative 18n. So we get 3n squared minus 17n minus 6 equals 3n squared minus 15n. And before this pains you too greatly, you will realize hopefully this, that both sides of the equation have 3n squared. So let's subtract 3n squared from both sides, and magically the squared term, not magically, it's mathematically it goes away, and we are left with what? We're left with negative 17 and minus 6 equals negative 15n. Yep. And that's just a way easier looking problem, right? It started out looking very intimidating. No problem at all. Now, let's add 17n to both sides. And we get Negative 6 equals positive 2n. Okay? And then we can take our negative 6 divided by 2 equals our 2n divided by 2. And what we get is negative 3 is what n is equal to. And must be A. I don't know what you think of my color. Um, I have fun with colors, and hopefully it doesn't drive you too bonkers that I'm writing in all of these different colors. Um, there is actually, believe it or not, a little bit of thought behind when I'm doing it, why I'm choosing to change colors at a certain time and how I'm keeping things the same. Um, but you might not see it. I don't know. Let me know if that's more distracting than helpful. Okay. Now let's round this out with this problem. This times this, over that times that. And we're going to get 12y equals 5 times 3y minus 8. Okay? And then that means that 12y is equal to 15y minus 40. Okay, well, let's get all the y's on one side. Isolate the variable, minus 15y, minus 15y. And what do we get? We get negative 3y equals negative 40. And then, of course, we're going to divide both sides by the coefficient. Oh, and I almost left the negative off. Focus on the negative. Need to see this. Okay. I always tell the kids, make sure that you're paying attention to sign. I need to do the same thing. And what do we get? We get y is equal to, and the negatives cancel out, but we can't really divide 40 evenly by 3, and so you can see in the answers they left things as improper fractions. So we get 40 over 3, and I'll just box that out. That's the answer right here.